Okay, well today we're going to be covering Ch.1-4, Properties of Real Numbers. The objective for today is to identify and use properties of real numbers. So make sure you jot that one down. That one was required for you to copy in your notes. Okay, and we're still working with the prepares for Ch.1-4.2, so we're still kind of going through the setup here. Okay, now we're going to move on to the properties. A little more complicated and less used necessarily as far as referring to, but they are used all the time. We just don't really speak of them a lot. Okay, and the first one we're going to talk about is the identity property of addition. Okay, identity is keeping the same, identity in that sense. Okay, it's staying the same. So when we look at this one, it is saying that if we take A plus 0, well, if you take a quantity and you add nothing to it, you still have A. Okay, so you're keeping the same identity. So if we were to take 4.5 and we're going to add 0 to it, that is 4.5. So what property was used? Well, this was the identity property of addition. Okay, it's adding 0. Okay, the second was the identity property of multiplication. Okay, so that is, again, we want the property to stay the same. So the question is, through multiplication, A times what will give us the same thing? That's right, it's 1. Okay, A times 1. So example would be like negative 12 times 1, that's equal to negative 12. It remains the same identity, and that's important to know. Okay, so multiplication just means you're multiplying by 1. Okay, the next property is zero property of multiplication. Okay, zero property of multiplication. This is an important one because this one's used all the time. It makes math real easy when you have this property come up. Okay, it's saying that if I have A times 0, well, what's anything times 0? Hopefully you know that. It's 0. Okay, so anything times 0 will always be 0, so this is zero property of multiplication. So you just take a big number, 120, oh no, we got a big number, we're going to multiply it by 0, and you get 0. Okay, so it's nice, easy, it makes math so much easier. Okay, the last one we have here is the multiplication property of negative 1. Okay, so what happens when we have the property of negative 1? Okay, fill in that blank. Well, you're going to have A times negative 1. Well, what happens there? Well, then you get the negative A. Okay, so it just changes the value. This is really helpful in more advanced math because you can kind of almost cheat the system a little bit. So we're going to multiply 9 times a negative 1, and what we get is a negative 9. So it just allows us to change the sign of the problem there by multiplying by negative 1. Okay, and these are equivalent equations or expressions there. Okay, we go to problem number 2 now, and what properties are being displayed. So the first one here, A, you have 42 times 0. Okay, well, yeah, that's the 0 property of multiplication. Okay, it's a real easy one. Then we have part B here, which property 10x plus 0 is equal to 10x. Well, there's addition, it stayed the same, 10x, 10x, so that's a identity. Okay, it's definitely an identity, but it's identity of addition. Okay, it's identity of addition. Okay, C here, we have 12 times 1 is equal to 12. Again, there's the same thing, it's being the same. So this is the identity of multiplication. Again, if you want to use the x, that's fine. You can go identity property of multiplication. Okay, and the last one, negative 1 times 5 is equal to negative 5. Okay, that was just the last one we did for the examples. That is the multiplication property of the -1. Okay, multiplication property of -1. It's just allowing us to change the problem. Okay, well, let's look at problem number 3. Simplify each expression. So we're just going to apply this. Now this is where we apply the problems here. So like this problem here, you have 5 times 3n. Well, by using commutative property of multiplication, we can take this and make it, oh excuse me, it could be associative as well if you change the order depending on what you do. We'll go ahead and put it in parentheses. We'll call it the associative property of multiplication. Okay, we can take 5 times 3. So what we're doing is we're grouping these two together instead of the 3 and the n. So that would be the associative. Okay, if we just move the 3 out there, that would kind of change the order, so that would be commutative. So we're going to take 5 times 3, which is 15, and 15 times n, we can't change, the n's a letter, so it's a variable, can't do anything else. There's the simplified expression. So we applied there the associative property. Okay, in this next one, we're going to do all sorts of things. We're going to start off by making it 7b plus 4, which is what property? That would be the commutative property. We change the order here. And then we're going to take the 7b and we're going to add that with the 4 plus 8. So we've moved the parentheses by using associative property, and then we're going to finish up by combining the 4 and the 8. We get 7b plus the 12th, and that would just be simplifying. Okay, we're going to go ahead and go to the next one, which is going to be a little more complicated because it's a fraction. We're going to take 6x. Because it's technically over 1, we're going to multiply that, because it was multiplication up top. Okay, 6 times x times y, that's all multiplication. Okay, there's really a 1y, sometimes it's tough, there's really a 1y down there. Okay, so what we're doing is we're breaking this apart and making it 6x over 1 multiplied by y over y, which is really, the same thing. Well, 6x over 1 is just really 6x, and then y over y, when you have something over something that's the same, that becomes 1. Okay, so that's 1. Well, now you'll see here this is the multiplication property, or excuse me, the identity property of multiplication, which gives us 6x. Okay, so there's the finish on that one. Okay, so we have the vocabulary. We talked about the equivalent expressions. Deductive reasoning. Deductive reasoning means using properties and basic reasoning skills to support ideas. It's basically just supporting what you came up with and what you did. In geometry, when you get there, you're going to talk about proofs, and probably a lot of you are not going to like proofs, but it's basically doing deductive reasoning. You're using the properties to support what you're doing. It's just providing why you did something. Counterexample is the next vocab, an example for a statement proving that statement is false. Okay, counterexample means being able to provide something that says that's wrong. Okay, so the primary place we would see that is in saying there's a commutative property of subtraction, because there's not. So we look at it and say, well, what's 3 minus 1? Can that be the same thing as 1 minus 3? Well, this would be a counterexample proving that that does not work, because 3 minus 1 is 2, 1 minus 3 is negative 2. Those are not equal, so that would be a counterexample to saying that commutative property of subtraction would work, because it doesn't. There is no property like that. Okay, problem number 4. Is the statement true or false? If it is false, give a counterexample. So essentially we want to provide why we know it's false. So for all real numbers a and b, a times b is equal to b plus a. Okay, this could be real easy, just kind of finding some numbers. We think about that, find some examples. You might say, well, what about 1 times 2? Is that 2 plus 1 going to be the same thing? No, so therefore this would be false. Okay, so real quick we come up with false. And an example that I'm going to provide you with is to say 3 times 2 is equal to 2 plus 3. 3 times 2 is 6. 2 plus 3 is 5. One example makes it false. It doesn't matter. You can find 20 other ones that work. One provides it to be false. Okay, for all real numbers a, b, and c, you have a plus b plus c is equal to b plus a plus c. Okay, so the question is that going to be true? Well, if you look there, that is a plus b plus c, b plus a plus c. What has changed? Well, we've rearranged the order and the parentheses here, which would be the associative and commutative of addition, which would work and would make that true. Okay, so again, if you have any questions, go to my webpage, check that out, go to discussion board and post a question, or make a post on Twitter and let me know if you have anything. If not, we'll see you tomorrow. We'll have a discussion and we'll go over some of the classwork. Have a great night.